we'll continue the session now. So first of all, this AI, the term artificial intelligence, is not at all new, right? We know there are a lot of hype recently, and we are working. We started working on AI. A lot of research especially in the corporate world, it became like very popular. Be it a startup or large organization, medium organization, everyone is focusing in AI. But AI, the term, is not new at all. In 1950s time, Alan Turing, he actually had written one article named like Computing Machinery and Intelligence, and then there was a test which is like now called Turing test, which is being used for different criteria of intelligence, right? And we try to judge the like outcome of any computing system, where the conversational content alone, which cannot be distinguished whether it is by a program or by real human. So if we cannot distinguish, then we can say like this particular system passed the Turing test, right? So that was the first, and then Professor John McCarthy, he mentioned about this term in 1956, right? So it's the era of AI, right? I mean, where started with the formalization of machine intelligence. Then this Turing test came, some kind of logic building, and then till the first decade, like from 1950s to 59, it got expanded, and then the expansion of symbolic reasoning, right? Especially like rule based, like how we can build the rules and then make it like in a symbolic way. And there are a lot of programming languages like Lisp, Prolog. The first one of the first I mean system was like Eliza, which came as I mean general problem solver. And after that, knowledge representation became very popular, right? Expert systems like in 1970s and 1980s also, it's mostly adoption of expert systems. And then how we can use this neural network. So there are a lot of different algorithms, including back propagation algorithm. Those came into the picture. Then support vector machines, Bayesian networks, those kind of algorithms which are especially for structured tabular data in the machine learning. And after 2000, right, when I started my AI journey, right? I mean, during early 2000, then the growth of different large scale data and kind of ensemble models, like, I mean, not only one particular, like random forest, different kind of boosting methods, and then speech recognition system, those came, right? 2010 onwards, the deep learning concept came, where we started like not only the feature engineering, like handcrafted feature engineering, can we do like, I mean, automated feature engineering, and then using GPU and all, right? So 2020 onwards, a lot of autonomous systems came, right? LLM got introduced, GPT came, Agentic AI got introduced, and that is our focus area now, right? I mean, the GPT series, multimodal transformers, autonomous agents, these are the technologies which we are using now. And 2030, what we are expecting mostly on the neurosymbolic or adaptive AI agents, where the human AI collaboration will have like more efficient, the trustworthy autonomous systems can be built. So, you can see my screen, right? I mean, everyone, anyone please confirm, because I'm only
Yes, we
talking.
can.
Okay.
Yes, we
Yes.
can see your screen.
Yeah, for better like bandwidth, I'm just turning off my video. I think the introduction is done. So let us go through.
Okay.
Now, there are different types of AI, right? I mean, the first bucket, what we put like mostly on the structured data or tabular data, right? Where we apply regression classification, which is like, again, advanced statistical computation, the forecasting, time series, optimization techniques, right? Dimensionality reduction, anomaly detection, even reinforcement learning. And nowadays, we are also using agentic way of reinforcement learning, recommendation system. Then NLP is like where we have unstructured data, but it is textual, right? So from there, can we have like sentiment or topic modeling, different kind of machine translation from one natural language to another natural language, summarization, content generation, right? And NLP also has NLU and NLG, right? Natural language understanding, natural language generation. So even the generative AI, if we consider, it is not new, right? When we started machine translation research, that time also we are doing generative AI. Why? Because it is NLG, one language it is being understood, then NLU, and then suppose I'm translating like say Hindi to Urdu, then definitely one language the system should understand Hindi first, then it is NLU, then it is generating Urdu, then it is NLG, right? So in that way we can we are actually working for more than 3 decades on these kind of generative AI. Then computer vision also, like a lot of applications, like whether it is started with like image processing enhancement, then object localization, segmentation, face recognition. So a lot of things we can do with emotion, gesture, and nowadays again image generation, video generation, right? Image generation was there, I mean, almost 2 decades back. I wrote a program for pencil sketch generation, right? Handwriting generation, so that can be done now. We see, like, I mean, this Gemini or GPT, they come up with like a lot of different new algorithms and different kinds of image and video generations, right? I mean, Nano Banana is one of the classic example of recent past, where we can describe the scene and it can generate that corresponding and with high quality and all. Then fourth bucket, what we consider is the multimodal and then generative and agentic, right? So it's not only text or only image, right? How we can deal with the hybrid kind of system where we have both of them, right? Video is there, text is there, speech is there, and so on. And this agentic, right? So definitely autonomous system were got introduced earlier, but those are like mostly like robotic process automation. So everything is like rule based. But now what we are doing, like each and every agent, we are actually making them intelligent so that they can interact with each other, and it will have like based on specific goal, and then a support of language model. We can orchestrate them. So today we'll learn few things, like few algorithms. Even these agents will learn automatically from the previous outcome from other data. We'll also learn like forward learning, which is it's in contrast with the back propagation algorithm. Back propagation is we learn from the error, right? And forward is we learn from positive and negative examples, just like MCQ, right? We have multiple choice questions where we say we get like 4 different options, A, B, C, D. Now only one answer is correct, the other 3 are incorrect or wrong answers, so we can call other 3 as false information or negative data, right? The only one correct answer is the positive data. In that way we can generate like, okay, these are the examples, and then how we can learn. Then different domains, right? I mean, I would suggest all of you to come up with ideas, and you can connect with me over LinkedIn as well. Like focus on any of these buckets of different domains, right? So healthcare, life science, or pharmaceuticals, or banking, financials, like, I mean, this insurance, BFSI domain, then retail, e-commerce, supply chain. I just clubbed few names together so that these are all very close or correlated, right? Transportation and travel, a lot of optimization, and then manufacturing, automation, real estate, where it requires like a lot of real-time monitoring. Then electronics, communication, definitely that is important. Education, e-learning, HR management, where we can actually apply AI and agentic AI, right? I mean, starting with like setting up with an interview process or resume screening, everything we can do it automatically. And it's not only the keyword search based, I mean, resume screening. We can have a lot of advanced technologies where we can see like, okay, Java and JavaScript are not similar or not same, but Java and C++ are similar because both of them are object oriented, and JavaScript and say CSS or HTML are similar because both of them are for web technology. But the keyword based search will give you the result like Java and JavaScript are pretty close, which is not, right? So it's not about only the keyword, it should get the context and all. Then renewable energy, utilities, sustainability. So United Nation is working on sustainability. We actually have like 17 different goals, like we call it like SDG, sustainability development goals. So these are defined by United Nation, where we can actually work on some of these projects, especially like healthcare, agriculture, right? So farming, food and beverage, these are also very important field where we should apply apply AI. Then legal compliance and all, social security. Then the BPA is anyway there, the customer support system, where we have to apply AI to reduce the human monotonous jobs. But it's not like cutting jobs. At the same time, we can get like more quality time to do better research or better work. Just like we don't walk, we use vehicle, right? It's not like replacement of leg. At the same time, we try to minimize our human effort, right? First invention of human, the mankind was will, right? And we are not using the same will. So even better to reinvent the will, because the stone age, the first will made of stone versus the will which we use in Ferrari, they are different, right? So although in English we have an idiom called don't reinvent the wheel, but I believe like we should reinvent, and that should be our focus area, like how we can make it better and better for tomorrow. And then this urban development, smart cities, along with the rural development, agriculture, farming, and so on. So what we'll be focusing today is like mostly the different features of the system that we try to achieve, especially like the nature should be adaptive in nature. Like, I mean, whenever some information changes, the goals and the requirements evolve, right? So even for agentic AI, when we are defining goals, we can actually think about an adaptive nature, because the goal of any particular task, right, it may vary. So today, whatever goal you have to achieve, tomorrow it may vary. You should be adaptive in nature, right? So right now you're all attending, say, this session for to learn generative and agentic AI, but tomorrow there can be a computer comes with quantum computing method, and that entire system got changed, right? So then we have to be adaptive enough, like, okay, now let's learn how to use quantum computers and AI on quantum computers, or QNN, right? Quantum neural network or something like. So we have to be adaptive. At the same time, the systems have to be adaptive also. Then it should be interactive, right? It should easily use like lot of interactive way. It needs to be very comfortable with respect to the users, and it can also interact with other processors, devices, like services. Not like one agent is only interacting with human. The multiple agents can interact among themselves, and they can interact with other like systems, right? Say for an example, WhatsApp is there. The entire data from WhatsApp can be used by an agentic AI, which can again send something to the like say sentiment analysis, and that sentiment analyzer agent, right? And that can again create another dashboard of like what's happening right now in a particular region based on the chats over WhatsApp. So then that processor, the device, those are all connected. Even a smartwatch can generate data, and we can leverage those, right? And make it for better understanding of the society and all. So contextual is also very important, like what kind of context we are dealing with, right? So even if it is a particular syntax, or related to time, location, what domain we are talking about, regulations, user profile, right? Many things are important, and what is the task, what is the goal of the agent, and based on that we can set the context. Because if the context is not right, we may not get the correct result. For an example, suppose we do suppose if I use a particular word, say operation, right? So now the operation, if I tell any of you, and which domain or context first comes or hits your brain, right? Anyone, please tell, like, I mean, what domain or context comes by hearing the term operation? I think participants are not allowed to unmute. So anyone can chat, and then Umama, you can actually spell it out.
ओके श्योर।
Yeah,
आप लोग सब अपने माइक को म्यूट अनम्यूट कर सकते हैं, बट फर्स्ट प्लीज हैंड रेज कीजिएगा।
yeah.
यस, हसन, हसन जिलानी,
Can you please
यू वांट टू
repeat the
से
question?
समथिंग?
Can you please repeat the question?
Okay. The question is when I'm telling about like contextual, the project feature, one of the project features we are considering the context, right? And then I gave an example. Suppose I'm using a word operation. Okay, now after hearing this word, what domain or context comes in your mind? There is nothing correct or wrong here, right? But I just want to see like what comes in your mind after the word operation.
Operation, like in the sense of executing something or what?
Hmm? But which domain when you are executing? So which
Domain related to AI.
no, just in general.
In the general sense, we consider the word operation like medical surgeries or
Very good.
something else.
Right. So the first thing which came into your mind is related to surgery. We call it like, okay, heart operation, eye operation, or something like. So that is the first thing in your mind. But then again, you may think, right, okay, in bank also we have banking operation. In IT also we have IT operations, as you rightly mentioned, like anything on execution. Very good. So this is what I am trying to say. Like in our mind, we already have a particular language model built, because what we learn, what we see, what we hear, what we put in our brain, that is the language model we are having, right? So the context is very important, which context we are talking about. Now if we focus only the context is say banking and financials, then the word operation means like some banking operations, right? It can be transaction, it can be loan, all these things will come into the picture. Then the kidney operation or heart operation won't come, correct? This is the thing what I am trying to mention. Okay, thank you. So next is iterative and stateful. So if you consider like the state diagram for any electronic device or digital electronics, right? The same thing here, right? I mean, what is the input, what is the output, and what is the state in between? Then how we can use this, how we can come up with the design ambiguity, or anything which is incomplete, and take that particular state, and then remembering the previous interaction. So that is very important for any conversational kind of a system, where we are actually having the previous state or previous statement, right, in mind, or in the memory here, and then using the same thing like chain of thoughts and so on. So finally, we are going towards the AGI method, right? Artificial General Intelligence, which is very much human level intelligence, and towards ASI also, artificial super intelligence, right? To have like wide margin, and from the AGI, which will have like the best human abilities, even better than human, right? And right now what we are doing is like mostly ANI, or artificial narrow intelligence, right? And we are going towards AGI, what I can say, but we still have to do like a lot of research and all. Now coming to the AI agents, right, from the generative and different other things, and the language model and all. But AI agents are definitely, these are software only, but at the same time, these agents can perceive, reason, act autonomously, right, without having any human intervention, and then it can achieve specific goals. So human prompts, definitely we can generate different prompts, and that set of prompts can again generate another set of prompts, right? So that is another level up, right? So if we think about like the normal software engineering, we when we had like the machine learning layer, that means like earlier we had input set of rules, and then we are getting the output. Then in machine learning, what we did, input and output we gave together to generate the set of rules. Now we are doing like, and one step above, like, okay, let us write some prompts which will generate those machine learning layer as well. Now agents are actually even to write those prompts automatically, right? So that is yet another level up, right? And then definitely the learning, continuous learning for improving the behavior over the time. So first I will do today is like a forward learning. It is a new term for many of you. I'm not sure you have read this article by Jeffrey Hinton, which is published in 2022, and Dr. Jeffrey Hinton actually got Nobel Prize in 2024 in physics because of deep learning. I mean, although it is computer science, but he got the Nobel Prize in physics because he used some energy principle to explain the deep learning concept, and how the neural network is providing this, and it's connected to the signal processing and everything, right, together in the energy principle and so on. So in forward learning, it's like two phases of forward learning, and where we will be using like training data. The training examples will have positive and negative data. As I mentioned in MCQ, right, multiple choice question, we have one correct answer and rest are incorrect. So those incorrect answers are the classic example of negative data, right? So, like if I ask like where is the capital of Pakistan, then the correct answer is Islamabad. But if I write Karachi there, then New Delhi there, and then Dhaka, then definitely the correct answer is Islamabad. But the other three answers are wrong. So that is negative data. So then the complete sentence along with the negative answer is a negative data. So that what we do even when we study, right, we also learn sometimes the negative part and say like this is not the correct one, right? So in that way also we learn, so that at the exam hall we should not do the incorrect thing. So same way our system should learn in a forward, and this is just in contrast of back propagation. So what we will do now, I will share this link. It has a code base, so please copy this URL. I am posting this URL into the chat box. Okay, so I think you have access to the chat window. I'm clicking it to message to everyone. So Umama, I shared the URL here, and those were,
Okay.
yeah. So what they have to do, they can just copy this link and paste it in their browser. They have to log in with their Gmail ID. This is actually Google Colab file. So
I think they guys are already working on collab, right, Usama?
perfect.
Yes.
Yeah, they
So
are
Joy,
working on
you
it.
can share your screen. We guys can follow.
Okay, great. Just 1 second. Yeah. So what I will be doing, let me just first explain. This is the original paper is here. I gave the link here. If you want to read the original paper, please read this as well later on. So this is by Jeffrey Hinton, the forward algorithm. Why I am teaching this today? Because this is very important for agentic AI. We cannot go back and forth for backpropagation algorithm, because in that we learn, I mean the system learns from errors, right? Whatever the result is, and then we try to minimize the error. But at the same time, not always we can tolerate errors, not always we can tolerate loss, even the loss function, right? We use the term loss function. So suppose we are appearing for an examination, and we cannot say like, okay, let's not study and then let's fail. Then we learn, okay, if I don't study, then I will fail, right? So that learning is costly, right? I mean, we may lose time, we may lose money, many things, right? So learning from error may not be a good approach. That's the reason, like Professor Jeffrey, he actually proposed this, and this is like some kind of example of negative data. So he used MNIST data, which is very common in AI, right? I mean, that handwritten character recognition from 0 to 9, 10 class classification, and this real 7 and real 6, and then he created some negative data by creating some mask and hybrid. So this middle portion, this particular thing is neither 6 or neither 7, right? Neither 6 nor 7. So, and he said like this can be used for negative data. So in that way, it's like a good paper. The link is already there in my code. So here in the top, right? And I wrote, I mean, I have read the paper and then translated that into Python code. So I'm using here Keras, and the framework. Let me run quickly what's happening here. And you can also run in parallel. Just take a copy. I mean, whatever is shared here, you can click here, file, and save a copy in Drive, and along with your name, so that even if you want to play it later, you can. Okay, so this is the network we are defining, the layers, and here the positive and negative data we are creating the same algorithm whatever he has mentioned. And finally, then this particular overlay to have the right and final loss, and then the partition training, and we are using uh, yeah, optimizer Adam, learning rate 0.03. Again, it can be customized. Then let us run. Here the normalization is happening. Here the batch size, the training data says 60,000, test data set 10,000, and forward network. This is the final model. 784 because the MNIST data, each image is actually 28 cross 28 pixel. So if I multiply 28 into 28, that is 784, and this 500 is the number of like nodes in the hidden layer. So this is the input layer. We have 784 nodes, and hidden layer 500 each, and output layer definitely number of classes, right, which is 10. Epochs I have 10 put 10 here, but in his paper he said like 60 is a good number to get better result. But for the interest of time, I am using epochs 10. Otherwise, it will take like long time to get trained, right? So I'm just running this with epochs 10, and let's see what's the accuracy. And here we are not using backpropagation, but at the same time we are using, because this MNIST classification, like I mean this handwritten digit recognition, is very popular. It's in Kaggle, right? And yeah, I think if you are aware of um, like computer vision kind of projects, right? So MNIST is one of the classic examples. If you have not done, then please complete the back propagation first, then learn this one so that you can understand the difference. So anyway, it is now being trained, epochs 1 by 10. So let's wait for that, and then finally we can have like the results. So everyone, please try, since the URL is shared with all of you. Then we'll go to the next example, because next example will be more like can be customized. So it is not whatever I have done is the final, because there will be a small task for one of for all of you, so that you can also tell me like what's the results you are getting. Anyway, so here the first epoch is done. It's going for the second.
Joy, Adam is saying if the training is too slow, you can switch to free TPU instead of CPU. Want to answer that? You're
Yes,
muted.
yeah, you can always switch to TPU. That's better. Good point. Yeah. So I'm using normal GPU, but if you're having that, please select TPU. No issue. I'm using high RAM GPU, but if the TPU is enabled for you, please select TPU. No issue. I think we are almost done. 7 by 10. So let's wait for I think 2 more minutes. So it will get completed. Anyone got the result? Final result? If you have better bandwidth or have selected TPU. Okay, done. Let us run this result. So test data is 10,000 records. Okay, so you can see 88.81% accuracy, but this is because of the 10 epochs, right? So if we increase the number of epochs, accuracy will be better. So this is based on the 10,000 records and the confusion matrix. So 940 zeros are predicted as 0, then this, right? So 10 classes in the x-axis and y-axis. This is a true level, this is a predicted level. Okay, so please try to understand this is not backpropagation algorithm, it's a different algorithm. And why it is important for agentic AI? Because we can actually reduce the error propagation, and instead of going with the propagating towards backward, we can actually think about forward learning, so that the agents would interact with each other and give the correct result. And definitely we need like more training sample, we need like more positive and negative data, just like in deep learning, right? When deep learning came, we had to have like a lot of label data, right? Without lot of label data, the deep learning will not work. But the traditional machine learning, the classical machine learning, where we had like handcrafted features, then even with small set of data, it would have worked. So as I mentioned, like I mean, the perceive, reason, act, and this autonomous thing and specific goals. These are very important for the agentic AI. So now what I will do, I will share another practical, which is actually on the agentic AI itself. And then what you can do, that will be a homework, right? You apply both the code base, right? I mean the forward and this agentic AI, and combine that together to have some meaningful project as well. So let me open this link and let me share also in the chat box. Someone asked like what is epoch? Epoch is just like iteration, right? For deep learning, we have to use epoch so that how many iterations are happening there. Okay, this is another link to everyone. Okay, no. Can you please open the second link as well, which is shared now?
आप लोग प्लीज सेकंड लिंक जो है वो ओपन कर लें ताकि we can move further.
Okay, here what I will be doing, I will be using one SLM from Microsoft. It's called Phi 3, which is Phi 3 Mini 4K Instruct. This is one of the popular small language model. Okay, so let us first install the transformers from Torch. So we'll be using PyTorch here, and then once it is installed, we'll be using the Microsoft Phi 3. So there is no limit of tokens. There is no credit card required to run this, and you can actually use your Google Colab, and it's free, and you can also play around, right? So whatever I'll be teaching today, it's not like that is the final thing, right? I mean, you can customize, but please take a backup, right? Best is like you take multiple backups to do your experiments, what kind of agents, because you can define different goals, you can define different agent types, right? And based on that, because this particular language model is not domain specific, right? So even if you want to define, I will share like where exactly you need to change the code, what I'll be doing, and then after learning that, please take it as homework so that you can do some experiments on this. Okay, it has run. So now in this particular code, right, I'm using a prompt like you are a task planner agent. Please listen carefully. In this prompt, I'm defining the goal for the agent, because now it is all like how to generate the text along with the SLM. Now, given a user goal, break it into 3 to 5 logical steps. Again, I'm repeating. The prompt is you are a task planner agent. Given a user goal, break it into 3 to 5 logical steps. But this is very much subjective. This is I have written, but you can again change, right? You can think about like you are a uh, say travel agent, or you are a healthcare customer support agent, right? So any of these can be used, because then the SLM will also help there. Then what I am doing here, I'm creating a prompt like you are an execution agent, and context, the context is coming from above, then the task, then we are splitting into multiple goals, because I have given this particular prompt to break it into 3 to 5. Given a user goal, again goal will be the input, and then we have to break it into 3 to 5 logical steps. After that, I kept like some examples. These examples are not again an exhaustive list ke sirf yahi chalega, right? So you can use anything else as well, but I just kept it for easy usage, because the next step, right, the next step, it will ask for to enter your goal. So if I run this cell, there is a small input box. Can you see this? Enter your goal. So what I will do, I will just copy any of these, right? Explain what, say any of the example. I am copying this, explain what a generative AI is, and give examples of good tools used in the business today. Or I can create this, create a learning roadmap for understanding artificial intelligence. Or I can select any of these, right? Content generation workflow. So suppose I'm selecting this, explain how multiple AI agents can collaborate to solve a research problem using planning and memory. So I'm copying this, the entire line, the sentence, and pasting here. Okay, this is for just for your easy usage, not like only this will work. These are some any examples I've just given, but it will work. After that, I pressed enter. Once I pasted this particular goal, so it is coming, it's coming there, right? Because I selected this particular example, explain how multiple AI agents can collaborate to solve a research problem using planning and memory. So then let's wait for a few minutes. It already got the goal, and then it started typing. So this text is generated by the agents. So it is actually step one, identify the research problems to be solved, define research problems, clarify and concisely. Step two, step three, and so on. Okay, now this is a small example, but at the same time, it is using the agentic AI architecture. It is using a language model, all right? So it's just the, you can say, and it is continuously generating. It's not stopping. You can see, it's not. Actually, I didn't put the break statement in the code, so it is still running, and it is generating the corresponding text, right? So if for you, like task 2, break down the research problem into smaller manageable task. Result, research problem to predict and model impact climate change and so a lot of things, it's coming from the language model. But the way we are defining the goal, the way we are defining the task for the agents is important thing, right? So that's the thing, that's the beauty of agentic AI, and it is not using any licensed product. Everything is free here, and it's running, right? So please let me know once you are in this stage, right? And then I will give you one task today, like the portion of the code, please again take backup, but I want you to change these portion, right? The first prompt, you take a backup, and the second prompt, right? These things, context let it be, but the first, this till this, like you are an execution agent. So the first prompt, if you change and give your own example as the goal, right? Enter your goal for the agent. Please use your goal. First, you run whatever I shared, right? This particular program, this particular code base, which is running for me. I think it should also run for you, all of you. And once that is run, then next task is change that and rerun, right? Any of the task, right? Think about any task, any domain, whether it is banking, healthcare, cricket, football, right? Don't worry on that, and put that, write the code here, like update this particular cell, instead of task planner agent and execution agent, change these whatever you like, and check what is the result you are getting. With that, I am stopping here, but over to all of you. Like once you are done, please let me know, and happy to interact.
Okay, Hassan raised his hand. I think he want to ask something.
Yeah, Hassan, please go ahead.
Yeah, I had to ask something that you have created a agent model who is specified to give the answers of the questions, right?
Hmm.
So I had to ask, there must be some data through which you have trained this model.
No, no, I'm using the small language model, Microsoft 5.3.
Okay, okay,
Nothing else.
SLM.
Bus, that's it. I'm not retraining it. So that's the reason, like what I asked, like in my code, wherever I mention like the prompt, right? The prompt here is mentioned like you are a task planner agent, where it is.
Mm-hmm.
Say this particular portion. You are a task planner agent given a user goal, break it in. So these prompt you can change in your code,
Okay.
and the next prompt also corresponding the next prompt, like line number 8. So line number 2 and line number 8.
Okay, okay, means you have created just an agent who is using an SLM, means small
Yes,
language
yes.
model.
Why I'm using SLM,
And
Hassan?
hmm, we are just giving them prompts, and it is taking out the answer, giving out the answers to us.
Yeah, so the SLM here is the language model, right? Now instead of SLM, we can
Yeah.
use LLM also. Why we are using SLM? Because it's like smaller, faster.
Mm,
Next is like the
okay.
architecture of the agents are here in this particular cell.
Mm,
So what we have to do here, the way I created or I crafted, you can always change it. It is
okay.
not like this is the fixed one. So I am providing you the platform. Now you can change these prompts. So line number 2, line number 8 and line number 18. Can you see the line number 2, 8 and 18?
Yes, yes.
This is like
They
subjective.
are visible.
It's not like यही करना है, ठीक है?
Mm,
But you are getting the structure, you are defining the goals, you are again giving the example of that. And please run this first. Run and then change. So the best way of learning is like whatever you are getting, then you change or customize in your way. Then you can learn actually better. I mean, easier as well. Any other question? Okay, I think,
We have two questions in chat.
yeah.
Adam Muhammad Safiullah asked, is it already fine tuned? How to fine tune it according to our specific tasks?
No, so the example what I am showing is not fine tuned right now. Okay, fine tuning can be done definitely using multiple approaches, right? Even if you are doing like something on on a particular domain, say you are working only on healthcare domain and a particular thing, then we can use like RAG based approach and all for augmentation and so on, right? And then how to use that is the second question, is how to integrate into existing pipeline, like develop customized chatbot for restaurants. Yeah. Here again, this portion, right, in the code, line number 2, 8 and 18, as I mentioned, right, you can actually think about this as a like a host in the restaurant, right? So write the prompt here in such a way like the agent will be created, which will be a like a chatbot responder for a restaurant. So it can be customized definitely. Now if you want to augment data from the restaurant's menu and all, you have to use some RAG based approach to augment. But fine tuning is not required at this stage, unless and until it is very deep knowledge required, because restaurant menus are all like common, I mean, not that specific to a business, unless and until it is very secret sauce like KFC, right? But anyway, they are not disclosing what they put in KFC. So, okay, I think he got the answer.
Okay, we
Next.
have next question from Sobia Noor. Yes, Sobia, you can speak now.
Hi, Joy. Thanks for this wonderful session and Data Seekho team as well. I have basically two questions. As you mentioned that AI is not a new term. Even in 1943, the concept of neural network were available. So my question is that why AI is so much successful in this current era as compared to the past?
Very good
And
question. So, yeah, yeah, please go ahead.
my second question is that in this current era, when every day we are being introduced to some new tools and terms, how I can be so competitive
Okay,
in AI?
both the questions are good. Thank you. So the first question, definitely the first question's answer is like when the concept of AI came in theoretically and all, or mathematically, right? The computational power was not that strong that time, right? Even when I started my own journey in AI, I had only 16 MB of RAM in my system in the desktop. Okay, 16 MB, not GB. 16 megabytes of primary memory, right? And now we have 16 GB memory, like primary memory in mobile phone, 16 GB RAM. So 1,000 times in a small handheld device. So and then some other things like definitely this advanced GPU, CPU, RAM, and all that came. Lot of different types of algorithms also came, and lot of data availability, right? Because again in early 2000 also when I started journey, that time this MNIST data or this Titanic data, the Kaggle challenge were not there. Even Python coding was not there. I used to write programs in C language on Linux platform, and it used to take like 48 hours to get trained a neural network model. And the data collection, well, like I mean manual data collection, I used to collect like handwritten recognition. So I requested my friends and colleagues, can you please write something on white paper so that I can scan and actually take the images from this. So that was like the beginning. So now we have like lot of data sets available, lot of computational power is there, lot of algorithms, sophisticated algorithms, packages, open source packages like Python. I'm not writing so much of code now, right? I'm using importing like say PyTorch, Keras, and this LLM is already there, SLM is already there. So we are leveraging those things which are there. So that is the first question's answer. Second answer is definitely we have to continuously upskill. So yeah, right? I mean, whatever is coming, please make sure like you learn, you read those research papers, right? I shared Jeffrey Hinton's paper also in the forward learning, the tab, right? It is there. So read the latest papers, be in the communities, right? The Data Seekho is one of the great community there. We are also doing the same similar thing here in Must Research, right? So talk to the right people so that you are continuously upskilled and upgraded, right? That is very important because at any point of time we cannot say like we know everything. So even I am continuously learning, right? And forward learning. So whatever is coming, the new algo and new papers or new invention, and try to invent, try to think outside the box. That's very important. Yeah, thank you.
Thank you so much.
Okay, do you guys have another question? You want to ask something? Anyone? We still have some time if you want to ask. Okay, then I think we should end this session. I truly hope you found this webinar insightful, practical, and valuable for your AI journey. And you guys, please give feedback. Your feedback means a lot to us. It would help us to improve and bring your even better learning experiences in the future. Please take a moment to fill out the feedback form. The link is being shared in the chat right now. Usama, can you please share the link? On behalf of the entire Data Seekho team, I would like to extend our heartfelt thanks to our amazing speaker, Joy Mustafi, for sharing such powerful insights on building custom agentic AI system using SLMs. Your knowledge, clarity, and real-world perspective truly made this session impactful. Thank you so much, Joy.
Most welcome and thanks for the invitation. Take care,
No worries.
everyone.
A
Thanks.
big thank you to all our participants for your time, engagement, and thoughtful questions. Your presence is what makes Data Seekho a growing learning community. Stay connected with Data Seekho, keep learning, keep building, and keep going. And with that, you can also join Data Seekho Academy for more structured learning and share your feedback for today's session too. Meanwhile, I will share the links in chat. Anyone, if you want to say something, we still have some time.
Thank you, and please feel free to connect me over LinkedIn. I'm very much active there, and if you have any other um, questions, I would love to answer even later over LinkedIn. Thank you so much. Thanks, Data Seekho team. Thanks, Umama and Usama.
Thank you so much, Joy. Thank you.
Bye.